So in this question, we're working with a static rigid body. We have the diagram, but I'm going to go ahead and make my own diagram so that I can add to it. So there's the particle, and we know that the distance from the wall to the particle is x. We have a uniform plank, so I can put the weight of the plank right here in the middle. The weight of the particle is 3 mg. The distance to the middle, since the plank has a length of 2a, is a. This little distance here is going to be x minus a, if I need to use that. And finally, over here, we have 2a minus x, the length of the plank minus x. Okay, and now I'll add on some forces that aren't necessarily given to us in the question. Because we have a string or we have a rope, we know that there's going to be some tension, and that's going to move away from the rigid body. And over here at the wall, there's going to be a reaction force, and I'll do that as two components, the vertical and the horizontal component of that reaction force. Okay, we're also told that tan alpha is 3/4, so let's use that with our standard triangle to find the other trig values. Okay, and now we can jump into the actual question. We've been asked to show that the tension is the expression given. So let's just go ahead and do our own maths and find an expression for the tension. I'm going to take moments from A. That allows me to ignore the forces that are at A, and I can just really just work with the three forces, which are the weight of the plank, the weight of the particle, and the tension. So the first two moments should be quite straightforward, and they're clockwise moments, and that should equal the tension multiplied by the perpendicular distance to the tension force. Okay, gonna go ahead and simplify some things we have. Let's expand some brackets. We know that sine alpha is 3/5, and we'll just keep on going to try and simplify. We're trying to get an expression as given in the question, so let's just take some steps to make t the subject and see how close we get to the expression that's needed. All right, and there we have it. 5 mg, a plus 3x over 6a, and that's the tension. So in part B, we've been told that the horizontal force exerted by the plank on the wall is 2 mg. So that's the force that I've labeled S, and we're asked to get an expression for x in terms of A. So I'll go ahead and resolve horizontally. Only two horizontal forces, the S that we're working with, and the horizontal component of the tension. All right, from here, I'll substitute in the 2 mg, substitute in the expression for tension, and substitute in the fraction that is cosine alpha. Okay, and from here, it's some rearranging to make x the subject. So we'll go ahead and rearrange. And we end up with equals 2/3 of A. In part C of the question, we're asked to find the value of tan beta, and the force exerted by the plank at the wall is an angle of beta. So we're basically asked what direction is the force at the wall acting. So we're going to resolve vertically so that we can get a value for R, the vertical component of that force. Okay, T sine alpha plus R equals 4 mg. Going to go ahead and substitute in our known values. Okay, we're going to try and rearrange to make R the subject. All right, so now I have R, which is 2.5 mg, and S was 2 mg. So I should be able to find the angle which their resultant force is acting in. Okay, so I'm just going to do a little bit of trigonometry. So tan of beta is going to equal 2.5 over 2. And then obviously we can go ahead to find beta, but we were only asked to find tan beta. So the answer, 1.25. And in this final section of the question, we're told that the rope will break if the tension exceeds 5 mg. So tension needs to be less than or equal to 5 mg for the rope to remain intact. So from that basis, I'm going to set up an inequality and go ahead to solve that inequality. Okay, so an expression for tension is less than or equal to 5 mg. Straight away, I see that I can divide both sides by 5 mg. Gets rid of a couple of unknowns. And I'm just going to rearrange to make x the subject. All right, so x must be less than or equal to 5 over 3a. And just to explain that in a sentence, for all of the marks, for the rope to remain intact, the distance of the block from the wall must not be more than 5 over 3a.